Hi, my name is Andrew Caldwell, and today we're going to do an experiment on the density of liquids. Now, first we need to understand what is density. Density of a liquid is determined by the mass of that liquid. So, something with a higher density will weigh more or have more mass than something with a lower density. Density is determined specifically by how closely packed molecules are in a liquid. What we will be doing in this experiment is creating a density tower to determine what liquids have higher density than others. Specifically, we're going to focus on the scientific inquiry or the scientific method of experimentation. So first, what we need to do is create a hypothesis to determine what we think will happen in this density tower. Now, me personally, I think that certain liquids in your house have different densities, and of course they do. So in this experiment, we're going to go through the materials and we're going to go through the results and everything that we need to do to get those results. So first, we're going to go through the materials that we need. First, you'll need materials such as your standard rubbing alcohol, baby oil, regular syrup, extra virgin or extra light olive oil, standard dish soap, chocolate syrup, whole milk, pure vegetable oil, and just a glass of water. Now, to do the experiment, what you'll need is a glass, a clear one, to be able to see where the densities are and where the different liquids end up, and something pipette type to try to equally put in the same amount of liquid in every case. In this experiment, there aren't any true risks to our health, so as far as safety equipment goes, everything's okay to touch with your hands, as long as you wash your hands in between touching each different liquid. As always, though, it's always smart to wear safety goggles, gloves, and something to protect your clothes if you feel necessary. As previously said, with any scientific method experiment, you need to create a hypothesis. Now, beforehand, I've already said that my hypothesis is that these different liquids will not mix and set separately along this cup. So once we have our hypothesis, now we have the materials gathered and we have labeled the materials all equally. And so we are ready to begin our experiment to test our hypothesis. Now first, what you'll need to do is start off with the chocolate syrup. Chocolate syrup will go all the way in at the bottom and make sure that there is a layer of chocolate syrup created. The best thing with the chocolate syrup here is to not let it touch the sides. It's very thick and you don't want that contaminating the other types of liquids that we have going on. Secondly, we're going to put in the syrup that we have. Now with the syrup, you want to do it as slow as possible, which is why I'm going to use a little cup like this, where I can put on this cap here and put it down into the cup. So that way I can control the pace at which the syrup goes in. I'm not sure how well you can see it here. The colors of syrup and chocolate syrup are very similar, so there's only a faint line in between those two where you can tell the true difference. The next ingredient we're mixing is our whole milk. This one's a little bit more tricky. It's a little bit more liquidy than the syrup was. So getting it to go in all together and at an even pace will be a little bit more tricky. The key here is to kind of control it with the side of the cup. All right, so here you can see a very distinct line where the milk is just sitting up there. You can kind of turn it too, and it kind of goes with it. It just sits up on top of it. The next ingredient we will put in our density tower is our dish soap. Same as before, consistency is key here to not go too fast. You don't want to rush anything in this. Just as before, there's a very distinct line between our milk and our dish soap. Our next solution that we'll pour in is just average tap water. Now the water did something very interesting here that we're going to note in our journal whenever we're writing down what happens in our experiment for this scientific method. The water actually seems to have went through the dish soap and brought up milk from the other layer, and now it's sitting up on this layer with the water. I'm not sure why, but that's something that we need to write down as a result of our experiment so that we can change our hypothesis into more of something that is a scientific explanation. Our next solution is our vegetable oil. Now, as you might have guessed, the vegetable oil did not mix with this layer of water that still looks like the layer of milk below that we need to write down. Our second to last solution that we'll be mixing is just your standard rubbing alcohol. Now this I'm not going to use the pipette for because it has its own form of it, and I'm just going to make sure to go very slow in pouring it. Now it is much harder to see because of the clear rubbing alcohol, but there is a distinction between our vegetable oil from earlier and our rubbing alcohol, as you can see there. So those two did stay separate. And finally, the final solution we have is just your average baby oil, which already has its own little type of pipette. Now I didn't have as much baby oil as I would have preferred, but you can see the faint line right above this rubbing alcohol here, where the baby oil is. So as I said before, the most important thing in any scientific method is your hypothesis. That's what we're doing here. We're testing a hypothesis that is given to someone to do an experiment on. Now, this was whether or not everyday household items have different densities. We discussed what density was earlier, and we found with our experiment that they indeed do. With the exception of water being a solvent, that is a very interesting way that it reacted. It went straight through our dish soap, hit this milk down here, and kind of mixed it in with its own water. That's something interesting that we need to write down in our results. So, all in all, our hypothesis was not entirely correct. However, it was majority correct. Now, this is something that we will record. We have wrote down everything in our experiment. So when you're doing a scientific method, a scientific inquiry, you need to write down every single step that you do. And that's why I videoed every single step that I've done here. The last but not least, the results need to be something that you can write down as a conclusion to say, yes, I was correct, or no, I was not correct in my hypothesis.